Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, so without further ado, the last talk is about giving away stuff, right? It's the free thing, right? The reason you've hung around and waited for. But this is Daron Green, who's going to be giving our last talk. Daron is heading up our Azure for Research program, and he's going to talk to you about how you can use the cloud for your research and beyond.
Actually, I'm going to do a range of things, but thank you, Chris. I'm going to cover a range of different subjects. I've got about 156 slides. No, I haven't. You've sat through a lot, so this will be a little bit lighter than some of the other presentations. Not that there's anything wrong with the other presentations, but what I wanted to do is explain to you a little bit about the umbrella activity that I lead with Dan Fay, who's chosen. Oh, he's there. He is there. So Dan actually leads the Azure for Research initiative. I help him with that, and you're part of it. Whether you realized it or not, the fact that you're here means you're part of the Azure for Research initiative. And you will have seen some of the imagery that we use for this. This is a sticker that we've just created. And the idea is we're the little lab coat wearing scientists, and we benefit from, and the personification of our cloud is this giant robot that does the number crunching for you. And the reason why I want to start with this is to share with you a very personal experience that I've had with the cloud. Because when we started out on this journey, which is about, I don't know, 8 or 9 months ago, that we Dan's nodding, so he approves of me saying 8 or 9 months, which is good. So 8 or 9 months ago, we started out and actually put a plan together for helping researchers understand what it means to use our cloud computing infrastructure, because it was originally built, as you've heard, for a different purpose, okay? A lot of the training material, a lot of the content, a lot of the examples that we were talking to people about was very business specific. And we knew that that didn't work, didn't make it accessible to researchers. So here's a picture of my kids. Why am I showing me a picture of my kids? This is Ben on the left, this is Jack on the right. They got to hear about the fact that I was working with cloud computing, and they'd heard about cloud computing, didn't really know what it was. So they asked me to explain. I said, look, it's a little bit like the computers that you currently have access to at home, that you play games on, but you're sort of logging in remotely, and it's not just one computer. You can scale up to a vast array of computers. Okay, so I've been explaining cloud computing to them for some time. I went off to a conference, and at this conference there were, I'm hoping none of you were at this particular conference, there were about 76 computing services heads. So these are the people that run computing services in universities in North America. All right, this was back in 2013, and I was talking as part of a panel discussion about the way in which the cloud is used by researchers, and many of them were saying, oh, no, we don't really need the cloud, our researchers don't use the cloud, they have no intention of using the cloud. And in nearly every case, their universities were using the cloud, their researchers were using the cloud, okay? And in some cases, there were very heavy users of our cloud, all right? And it came as a surprise to them. And for many, it was quite disruptive, okay? Because suddenly they went from being the gatekeepers to computing to being sort of disintermediated. The researchers could get a grant and go straight onto Azure and just start spinning up machines and getting work done. And that made them feel a little bit strange. What's their role? It's a little bit like libraries that used to be the gatekeepers to the sacred texts. Well, now they have a very different function about curating digital assets or discovering digital assets. So what I came home from this particular conference and was saying, look, these guys don't know what's going to hit them, okay? Computing is changing. There's a paradigm shift. And my kids were saying, well, what do you mean? And I said, look, some of them were anxious, okay? Great sense of anxiety. Their loss of status, okay? Loss of control, loss of influence. They're outdated. They feel threatened. And what I was saying to my kids was, what they should see is that actually there's some freedom that they can get from this. They don't need to be trying to deliver stuff, the same sort of stuff that they were doing before. And actually it's an opportunity then for it to innovate. They need to change the nature of the services that they're providing to the folks in their universities or in their computing communities, research communities. Little did I know how this would come back to haunt me. These guys then said, okay, that's fine. That's great. Can we play with the cloud? I couldn't think of a good reason why not. I'd given them access to computing infrastructure before, so I said, okay, fine. I then showed them, if you haven't already logged into Azure, hopefully you will do at some point in the next few days or weeks. I then showed them how to log into the management portal. I didn't give them the password, all right? But I then, I logged in and then showed them, look, this is how you spin things up. This is how you get attached storage to a virtual machine that you've created. This is how you do an endpoint. And then they said, okay, Dad, we got it. Which is sort of code for just leave us alone, get out of it, we know what we're doing. And I said, but no, let me show. No, okay? Sure enough, I realized at that point that I really represent two things for them. I'm money and technology, and that's it, all right? And they'd just gotten access to some more technology, and they wanted to be left alone, okay? Fine. About an hour later, this is what the screen cap looked like. And for those of you that know Azure, you'll recognize most of the dashboard. You'll see that they've got a storage account at the top. They've got a couple of you've spoiled it already. Minecraft. All right? They've got Minecraft running. And, okay, fair play to them. They're, it's pretty good. And sure enough, this is a fairly recent plot, and I'll explain a little bit more of the sort of stuff that they're doing. They've spun up, I think originally they just had a single CPU instance. That's all they needed for the two of them to sort of play. Okay? At least that's what they did for the first day or two. All right. And actually, I felt quite good about this because I'd had a tiny little PC that I'd been using to run Minecraft at home within the house. All right. And I was doing the patches, I was doing the server updates, I was doing performance monitoring. They'd be complaining about latency every now and then and go and have a look if something was going wrong, if I could stop something streaming so that they could have a better gaming experience. And every now and then I took the firewall down so that people could actually play on the same server. So friends that were local could play. And it was, it's quite an overhead for me to have to do that. Okay, so I was quite pleased at not having to do this stuff. They were really pleased because, hey, they're running on one processor, but they can scale it up if they wanted to. They were doing data sharing, so they were both putting files onto the Azure server and then sort of working on them. They were having shared experiences, as I would find, with their friends. And actually, they started collaborating and innovating within just a couple of days in ways that I'd never imagined. And I want to show you what they were doing. So they were given an assignment. This is totally unrelated, all right? They just had this assignment where they had to work together as part of a team to design a space station, explain the function of the different parts of the space station, and how they arrived at the overall design. So they came back saying, hey, we've got this assignment that we've got to do. They came back from school and said, we've got this assignment. Great. They ran upstairs, started beavering away, and then after about 10 or 15 minutes, I wandered by the bottom of the stairs, and I can hear Minecraft noises. All right? So guess what they'd done? They'd opened up the Minecraft server to the group of friends, and they were using the instant messaging in Minecraft to coordinate the different bits of the space station. They were then screen capping, like this, screen capturing and pasting it into PowerPoint. And they were putting a narrative and notes onto the design points. And they were doing this, they were flying into or walking into different parts of this and then taking the screen caps. All right? This is what they did when I gave them access to the cloud. All right? So from my perspective, I then went through all of these things. Anxiety, loss of state, loss of control. All right, that's not what I expected them to do with it. Okay? I was the one that provided IT to them. All right, that was my function. Now I'm just a source of money and nothing else, all right? And I actually, literally, I went through, no, you can't. I was, and then I realized, I stopped myself. I was repeating exactly, the sort of paradigm shift that was threatening the folks at the universities delivering computing. I've got this with my own family. All right, so what do I have to do? Well, it gives me some freedom. I have to find other ways of innovating. And I'll come back to that, okay? All right, so that's a sort of very personal experience. Here's the magic, though. Here's the real magic, I think. I'd never give my kids access to a supercomputer, or at least I wouldn't have thought of. They'd never get access to a supercomputer. But the cloud gives them that. Exactly the same infrastructure and fabric we've used for running 20,000 compute cores to analyze, billions of pairs of genetic markers. So this is work by David Heckerman's team as part of this sort of research that Tony is in charge of. So this is just one example. There are other examples that you've heard over the past couple of days. But for me, there's something profound happening when my kids can use the same infrastructure that can do this type of research, okay? And that's a fundamental change. They'd never get an NSF grant, they'd never get a DOE grant, or maybe not for a few years at least, but they're already running on the same infrastructure. Pretty remarkable. All right. So what are the implications of this? And they go obviously much deeper than the sort of time that my kids can spend playing Minecraft. This speaks a little bit to some of the issues or comments that we're wrestling with before and talking about over lunch, of the way that the cloud can even ultimately change the economics of the way that science is done. So imagine for a moment you get a proposal approved. You might have to go through some recruitment, depending on whether you've got people resources available. But actually, pretty quickly, if you do have people in place, you can deploy a community or own research group virtual machine in the cloud. You can extend your models. You can do whatever simulation work or analysis that you want, and then simultaneously, you can do the following things. And again, this is pretty much uniquely enabled by the cloud. You can publish your paper. You can publish the virtual machine, the software stack that you use to conduct the research. You can publish it in an open way, or you can publish it in a restricted way to your community. You can publish the data. Other people can reproduce your results. The scientific method actually is more enabled by the cloud. Without this sort of approach, you're begging to get access to people's software, or you're begging to be given access to their data. Can I have your data? The paper may have been published, but as funding agencies insist that the data generated from research that's funded by the public purse be made available, the cloud actually gives us a mechanism for doing that. And then perhaps the most controversial in this is, and this relates to a sort of positioning paper that Dan Reed, Dennis and I wrote with Elizabeth Grossman, who's one of the policy folks here in Microsoft. We were asserting that actually allows the opportunity for researchers to create a marketplace, okay, for their data or their research services to be procured. Okay, what do we mean? What do we mean by that? We mean that industry actually can discover these published virtual machines or some of the exposed data, and then say, okay, could you run that analysis, but on our data set, which is also in the cloud? So it gives an opportunity for researchers to offer different services, and those services could be at a range of different levels, okay? So it could be that you've got some runtime, special runtime or database services, that you do some special data management or application services, or that you're going to provide just some fundamental research. If you give us access to your data, whatever the commercial company is, we will do some analysis. So in the same way that you can publish your capabilities here to the research community, you can actually create a marketplace, or you can be active in a marketplace where you expose some of these to commercial customers. Why would you want to do that? Well, you generate an additional revenue stream, okay? Maybe you fold some of that back into your core research activities. Okay, so with a lot of this in mind, we put together the Azure for Research initiative. Okay? And what we're doing is really a range of different things. We're providing free access to cloud computing. We're offering the training that some of you probably did at the beginning of the week. And we're providing some technical resources, and I'll mention some of those, and some support capabilities. Okay? So I'm going to step you through some of the things that we're doing there. The first one of these is the training. We've just finished, so the last quarter or so, we've done 14 training events. We've got another 14 scheduled to the end of Q4. That takes us up to pretty much to the end of the year. If you're interested in hosting training, let us know. Dennis will guarantee that we'll deliver it at your university. No, we can't guarantee that we can deliver it at your university. No, we are interested in knowing, though, if you think the training that you've done this week, or if you're not aware of the sort of details of the training, we can take you through that. If you think it's going to be useful to locally at your universities, you can see where we've already deployed, and the scheduled ones are in this sort of beigeish color. So that was the training. The other sort of key thing that we're offering, if you're not already aware, is the awards. This isn't money that we give you, this is access time on Azure. These are Azure passes that last for a year. They're worth about 180,000 core hours, approximately 20 terabytes of data. That's roughly the sort of footprint. You could use that allocation more quickly than a year. If you did, we'd probably ask you what you were doing. Not in a negative way, like, what were you doing or what were you thinking, but in a, hey, what were you doing? All right, how come you used it so quickly? Because, we're just interested in what the workloads that you're finding work really well, okay? And typically what we're doing, if people do consume their allocation more quickly than a year, is, we ask them the question, what are you doing? And then we'll probably just grant you another allocation if there's something that you need to complete. All right, so we're very flexible. And right at the moment, Dennis, correct me if I'm wrong, but we have no hard limits on those allocations.
Correct your limits.
Okay.
Even on the number of allocations?
No, I mean on the footprint that we're granting to people.
Yes, we have.
Okay, we are, okay. So what does it mean to actually apply to one of these? This is pretty much it. The application process is pretty much what's on this slide here. So you should be able to answer all of these fields. If you can't, don't apply, all right? But it's things like name, all right, and position, title. The hardest thing you have to do is we want a little abstract and then a proposal, no more than 3 pages. We struggle to stay awake if it's longer than 3 pages. No, 3 pages is usually enough for us to get a handle on what it is that you're proposing, okay? So the relatively short, relatively lightweight things. We take submissions every 2 months. So on the 15th, that's the middle, of all even months, all right? So we do actually, if you submit before the 15th, we will take a look at it, but you sort of don't be wanting to submit on like the 17th or the 19th of the even months, because you'll have to wait a couple of months, okay? So typically we take proposals we evaluate them every 2 months. We've granted 183 projects covering 28 countries, and you see the geographical distribution there in a glorious pie chart on the right-hand side. There's nothing geopolitical in these allocations, so don't read into this that we have any particular, desire to not invest in Germany. That's just that we haven't had as many proposals from Germany. There's a little bit of an artifact of you see, wow, that's quite a few from Brazil. Okay, so why is that? Well, we did the training in Brazil as one of the first places, so we get a lot more, we've got more proposals coming in from Brazil. So, if you don't see your country represented there, then stick in a proposal. As well as these every 2 months, this evaluations that we do, we have some special calls. There are some things that we're sort of particularly interested in receiving proposals for. We recently had one that was calling for virtual machine. So a virtual machine that may be relevant for your community, then we were particularly interested in, would you develop those and then publish them? We also did one in conjunction with the White House on analysis of climate data. We're going to do a very specific RFP for Brazil. So we did our original training 6-7 months ago. We're about to go back and do another round of training. And we're going to have a call shortly for MATLAB use on Azure, but I'll come to that in a second. We've got a major event coming up in the summer in Russia. Some of you may be involved in that. But we're also open to suggestions or proposals. If there's other things that you think we should be asking for here, if there's other events that you think we should be creating to help us understand the way that researchers want to be using Azure, then just let us know, okay? Pretty much.
In the previous talk, you should have a Python call.
We should have a Python call.
Or IPython.
IPython. Good suggestion. Okay. So those are the, still research awards. So delving in a little bit deeper, by discipline, I wonder whether we should do the sort of analysis that Jeffrey's been doing on the nature of the application and using some of the taxonomy that you've got. But this is just by discipline. I'm rather disappointed by the chemistry showing, given that my PhD is in chemical physics, so that is disappointing. A lot from computer science, and then digging into this segment here, you see that there's quite a long tail, but machine learning, big data analytics, that sort of stuff. Not that these are necessarily completely distinct, but it gives us some sense of the sort of workloads that people are targeting in here. And I think, Dennis, correct me if I'm wrong, which you probably will, a lot of the things that we're seeing in the computer science is where there's a computer scientist working alongside another. Yes, I got that one right. Thank you. Good.
The bio area is usually a bio person in charge of working with a computer science person. And that's why genomics looks small there, is because it's all classified in bio.
Okay, good. Okay. I'm not going to go through these. Some of these you've actually had some in-depth presentations on, but this is just a little bit of a sample. I don't think Harrison Ford is actually one of the PIs, though. He did pose for the photo, which was rather good. Yeah. Excellent. All right, so 2 common requests that we've received, and this is us responding to the requests that we've been, so from some of the training event, from some of the RFP winners, we get questions like, okay, why do you have MATLAB running in the cloud? And how do you help me do just really simple parametric sweeps? So here are sort of these are our responses. So the first one is making sure that MATLAB distributed computing server is working on Azure. And this is just a graphic to support that claim. To use this, you need to have a MATLAB client. All right, you need to have a license to a MATLAB client, okay? And then you can then schedule onto a Windows HPC server from which you can then provision additional resources up in the cloud, okay? We've just gone through the process of agreeing the licenses that we own for this side, so we provide the licenses on this side, okay? You need to come with the license for the client at this side.
So does that mean, though, that you have to have a DCS license on the client?
You have to have it on this side.
No, but what kind of
What kind of a license do they have?
Client only. You just need the client license. We provide the distributed computing server licenses.
Yeah.
Yeah, the academic. You just have to have an academic version of MATLAB. That's all you have to have. And MathWorks will activate it for you, verify that you're a user, and we're working with MathWorks on this.
Okay.
So,
All right.
we know there's going to be a follow-up for this, and what we're looking for is actually, and this isn't broadly announced, okay, so most likely from the constituents in this room, we will fully populate the roughly 5 sort of early adopters So we're looking for a few folks to help that are familiar with MATLAB, that have workload that they'd like to push up into Azure. If you're one of those people, and already you've probably noticed that Wenming is active on this, then this is the email, and just put as your title MATLAB pilot, or just talk to him before he escapes at the back of the room. Okay? We will, once we've ironed out this, all right, once we've had those early adopters sort of working and checking that things are behaving in the way that we want, we will have an RFP that more broadly invites people to propose workloads using this, okay? But we don't want to open it up to a large number until we've ironed out all the problems. So there may be problems. We need whoever those early adopters are to be a little bit sympathetic that, you know, things may not be perfect on day one. Yeah, we're not coming in with nothing. So this is the first of a 64-page.
No, not quite that bad.
Okay.
Minus graphics is about 20 pages. It's on the technical papers section of Azure for Research website.
Okay. So this is something that Wenming's been authoring to help people get started. It explains exactly how you set all of this up. Okay. So that was the first thing that we're sort of we're quietly announcing that we'd like you to engage with us on. The next one is something that we've codenamed internally Simulation Runner. Okay. And it allows us to do really just a scale out of some existing sort of contained application. This could be Python, it could be an XC, it might be the MATLAB runtime or some other program that you've got. And the way that this works is, and you can ooh and ah at the animation, if you like. This is Wenming's handiwork. It looks hideous from here, I have to say. Oh no, it looks good from here, but standing right there, everything's out of shape. So what Wenming has built is effectively a portal from which you can define the nature of the parametric sweep that you wish to do. You have on your clients or end user the ability to point it at a particular application, which could be in Dropbox, it might be on some local storage, or it could be on some Azure storage. The portal effectively defines the queue. The queue then gets cranked through and then sort of delivers. You can monitor the activities and you'll see the status, effectively the status of the workload. It's a relatively simple infrastructure, but we know it's a very common request for the sort of pleasingly parallel, some of the pleasingly parallel workload.
That was half the jobs.
It's half the jobs. You can understand it's a very common request for us. So rather than have everybody instantiate the same sort of scripts, what can we do to help?
In 1988, I said that was 20%.
Yeah. Okay. Ooh, lovely animation. All right, so again, what we're looking for is some early adopters. These are, I call it embarrassingly parallel, okay? Pleasingly parallel is a little bit more sophisticated. As somebody that used to parallelize CFD, computational chemistry codes, finite element codes, these sorts of things, I would get embarrassed about claiming that I parallelized them. So, you probably already know the sort of workload, but you know it's image processing. We've got a vast array of images that you wish to analyze, or some design optimization where you're changing some of the parameters on the design and want to go through maybe a full simulation or optimization on each one. Again, wenming.msdn@live.com, slightly different title though, Simulation Runner Pilot. Okay, previous one was MATLAB. If you put Simulation Runner. And you can see a little bit of the screen cap of the simulation runner itself. Okay, some other things that that have been requested of us are technical examples, design patterns, these sorts of things that are relevant to research. If you remember, I said that a lot of the previous examples were great if you're in business, so what have you got for researchers? We've got technical papers. Other people have been asking for, okay, that's fine. How do I get data in? I've got these devices, or I want to build devices, and I want to spray data up into the cloud. How can I do that? So we've been working on these two. If you were to go online at azureforresearch.com right now, you will see that we have technical papers on each of these topics. So there's some early overview just to get people started. And then we get in a little bit more detail, a little bit more sophisticated as we go through. So HPC and technical computing, scaling a cloud service, installing Blast, using things like the service bus, and Python. Okay? If there are gaps, if you say that's all very well, but I really need to do this, you don't have anything that explains how I achieve this particular outcome, let us know. Okay? These were ones that we thought, just from the initial feedback, made sense. But if there's other things that you think we should be doing, please give us the feedback and we'll...
So how do I make Azure a sort of SDN-enabled part of either the IU or my research group's compute infrastructure? That would be, I think, a broadly useful white paper.
Yep. How you scale out from on-premise.
How would I have you as the cloud bursting, or whatever you want to call it, resource provider, and just have it conveniently linked in using these remarks from the nice fellow who talked earlier today about how SDN and RDMA and things like that. There was lots of interesting ideas there.
Yep. Should you hear folks at the back? So, okay. So, yeah, I know you know. I'll just in case they want to comment. So, Jeffrey's request was, could we have one that explains how to burst out from local premise, on a university campus or in a department up into the cloud? Yep. Yes. Other things that we can do. So. We can also give other sort of technical help on if there are architectural issues that you have, or if there are particular code samples that would be useful, please let us know. I've mentioned the simulation runner early adopters or beta testers. If you're having technical problems, then we have a support email that you can use. So this is where we have a third party that will help solve technical problems. We work alongside them. They just help us deal with some, if there are sort of volume issues. So that's a useful email to sort of note down. It's not at Microsoft.com. Okay, this is a third party that we've commissioned to help us answer some of the sort of technical problems. And if you do plan on putting a proposal in, feel free to contact us. The sort of central contact email is on the web. If you've got a preferred member of the team here, feel free to email them, and they'll work with you on helping tune the proposal. Okay. Okay, so what I want to mention now is a conversation that actually I have relatively frequently about how you can build your own devices and get them to communicate with the cloud. And this is going to bring me back to where I started out a little bit. So I want to introduce to you something called Dotnet Gadgeteer. And there's a little box of tricks that I've got back here, which is actually one of the Dotnet Gadgeteer kits. And just to give you a sense, those look very big when they're projected on there. So what is it? This board here is this. So what we had found, this is predominantly driven by the researchers in Microsoft Research Cambridge, who were trying to innovate by constructing lots of different devices. Okay, and they built things like cameras that would take photographs intermittently and record other data to record a day in a life of somebody that maybe has memory problems. And by reviewing information about the day, at the end of the day, it would refresh their memory such that they could actually recall things over a long time period much more successfully. So this was Steve Hodges and his research team, Microsoft Research Cambridge. That was one device, and then there were other devices that they wanted to maybe do other types of sensing in a home setting. And they realized that they were having to create from scratch, pretty much, the sort of base components. And they said, look, this is silly. Let's go to some of the hardware manufacturers and get them to build boards which we can just plug other devices into. And that's what spawned the Gadgeteer project. It's programmed from Visual Studio, uses the .NET Micro framework. You can program in Visual Basic, you can program in C# if you wish. And it doesn't look particularly elegant. That's the same board here with a range of different devices clustered around it. This is a little LCD touch screen. Okay. This is an SD card holder. There's some LEDs, there's some buttons, there's a joystick there, a camera. There's an Ethernet port there. That's how you power the thing. It can be a little battery pack, or it can go into a USB. And really, it's an incredibly flexible way of constructing sensing. Temperature sensors are sort of standard issue for these things. Temperature, humidity. You can have soil humidity sensors. There are hundreds of different devices now that have been produced for this. And it's the sort of thing that you can go from having nothing, or the kit in the form that it is here, just in the box, to something working within just a couple of hours. Okay, there's no soldering required. You just plug it together. You can get Bluetooth interfaces. You can get what else have we got? We've got Wi-Fi connectivity. So you could have something relatively simple, low power. You can get GPRS as well. Yeah. So it will connect to the cell phone network. So relatively simple, easy to construct and deploy, and then send information back to you or back up into the cloud. All right. I won't go. I've mentioned a lot of the stuff that's on here. This is just one example. I built this. Well, the Visual Studio built this. This is me constructing an FM radio. This is the FM radio module. I then put on an infrared receiver and have a little key fob, which is here, that I used for tuning it. I didn't bother putting on, I did put the display on actually. So that's the back of the display. And by pressing up and down, you can tune the radio. On the display, it would tell you which station you listen to, which song track. You can see the volume. This is it actually constructed. You can see it's listening to channel 94.9. This is actually in a hotel in Moscow. And I went over and was building this on the flight. Which brings me to a note of caution about the way that the crew of airlines view that sort of electronics. And they get rather anxious because, they don't know what it's doing, and you look very suspicious, and there's conflict going on in the Ukraine, and they start talking about strapping your hands to the arms of the chair. All right, so, but other than in flight, it's a really good idea to get one of these kits and start programming it and playing around. Which brings me back to these guys, because you can guess what they want to do, perhaps. They want to take one of these kits, work with that group of people on the top right, and reproduce something that Kenji's colleagues did and Kenji was part of, where in this case, this is a Windows mobile phone sent up on a weather balloon, so it's at 80, 90,000 feet, something of that magnitude. So Kenji was very graceful. He came and gave a presentation to these Boy Scouts and sort of inspired them. Now, this won't be sending back data to Azure, all right, because there's no network up there that they're going to be sort of in communication with. But it sort of brings us full circle onto the sort of ways in which people can now build devices, and they're going to be recording scientific data as this thing goes up. They're going to be analyzing it when it gets back. But we're just at the start. It's now commodity electronics that you can use to do scientific data collection. And these guys have access to the cloud as well. All right, so this is just one sensor they're going to be sending up, but you can bet your life that within 6 or 9 months they're going to be thinking about, okay, what else could we be doing? They've already been talking about the fact, what if they've got a few more kids and package them up and threw them into Puget Sound? All right, and let them sort of float up and down. They can look at the patterns. They'll get signals back every so often, all right, if they can see a network, because the Wi-Fi cards can scan for open networks, attach to a network, pump some data back, okay? So, all right. So that then gets you to the problem of, okay, how are you going to get all this data back from multiple devices? There's the service bus infrastructure that we have within Azure. But I want to talk to you a little bit about another project that we have for managing. You hear about the Internet of Things. Well, we have a project called the Lab of Things. I'm going to play you a short video that explains that. And hopefully the volume's going to be high enough. You may need to be quiet.
Lab of Things is a flexible platform for research that uses connected devices. Meet Albert, a researcher who builds and deploys connected devices into people's homes. Researchers like Albert work in many different domains, including healthcare, energy management, and home automation. When Albert wants to conduct a research study, he needs an easy way to deploy his connected devices into a large number of houses, ideally geographically dispersed around the world. To simplify deploying sensors and devices into homes, Albert installs a Home Hub, a Windows computer running the Home OS software. The Home Hub supports discovery and setup of several different types of devices, including Z-Wave devices, IP cameras, and custom devices built using Microsoft .Net Gadgeteer. Albert can extend Home OS to work with other devices as needed by writing simple drivers. For example, if Albert wants to study a new sensor he invented that detects when people fall in their house, he writes a driver and then a small application to connect to the Lab of Things platform. He can then easily store data in the cloud, remotely update his study if he finds a problem, and monitor the status of his deployments across many different homes. Marie is another scientist studying aging in place. Like Albert, she uses Lab of Things to deploy sensors in many homes that she can easily monitor. Marie realizes that she and Albert have recruited similar participants in different locations. Because they are both using Lab of Things, Albert can deploy his study into houses Marie has recruited, and Marie can deploy her study into some of Albert's houses. Lab of Things enables researchers to share data, code, and participants, lowering the barrier to evaluating ideas in a diverse range of settings.
So the one caveat I'd make to that is it sort of implies that you're deploying globally and you're collecting data over national boundaries. I'm not quite sure that there's a lot of that happening, but just from a very common scenario is one in which people wish to deploy sensors in houses, in a particular cohort, another part of maybe the US, people also want to deploy, and then you realize you've recruited roughly the same type of people, and you want to be able to increase your number of locations. And if you've set it up using the Lab of Things and the sort of software fabric that we've got, you can easily deploy and monitor. Okay, so it's a very, very common problem that we've seen, that people without this sort of middleware have had to sort of regenerate or recode, create drivers, maintain a whole load of software. So if you have an infrastructure or if you have an intent to deploy sensors anywhere, then have a look at the Lab of Things as something that will really accelerate you through that process. All right, let me just get back. And you can obviously type Lab of Things into your favorite search engine or Bing, or you can have a look at one of these web links. If you've got any comments or any questions, then just contact Lab of Things at Microsoft.com, and it'll be routed into our research team. Okay, so just to give you a summary. I haven't really labored this because I think I would be preaching to the choir somewhat. The cloud is, without doubt, for me at least, a genuine paradigm shift. I've added education here just from when I look at the way in which it's transformed what my kids can do and now how they're talking to their friends about of tackling assignments that they're given. It's genuinely transforming the sort of research capabilities. And I would argue that for those that wish to, it can actually provide a new economic model for the way in which research is funded. Not for everything, not for all data, but it gives the opportunity for researchers to make available their capabilities in a marketplace in a way that maybe wasn't so easy before. We are offering the Azure for Research training. Some of you have taken it, some of you don't need it. If you think there are people that do need it or you want to host some of the training, just let us know. The Researcher Awards are a great way of you not spending any money and getting access to a lot of compute infrastructure. There's the open invitations every 2 months. We run these special calls as well, such as we're doing for MATLAB. And we've got a lot of other technical resources, the papers that I mentioned, Simulation Runner Gadgeteer, and Lab of Things. And if you didn't want to write anything else down, then the catch-all for everything is azureforresearch.com. That's where you'll find all of this and lots more. Okay? With that, I'll just say thank you and give you 10 minutes back. Thank you.
And if you still don't want to write anything down, we have postcards with it written down.
I was wondering, for your research awards, what's the threshold for those? Like if I wanted to explore using Azure as a data processing platform versus my own Hadoop cluster versus, Amazon, but I don't really have a defined research, goal that's going to produce like a paper at the end of it. It's more like, see if this is a computing paradigm, if you guys are offering better things than somebody else. Is that within sort of the thresholds? And also, is there a limitation on like it must be a professor or a department, or can it be staff researchers? Can PhD students get awards, but then they probably don't need 180,000 hours? They probably need 5,000 or something.
Yeah. So okay, so to justify an award, there needs to be something in there, or not. I feel like playing around with Azure, maybe. All right. So you're going to put some workload on there. So you should just indicate what that is. There are a lot of folks that are doing some pretty good work on here's Hadoop running on Amazon, here's Hadoop running on these other platforms. And we actually have a project with Barcelona Supercomputing Center where they're going into the real detail of actually for this hardware, for this configuration, for this interconnect, this is the way for this type of workload you want to put the dials, because Hadoop has many different configuration points. So there may be something that you suggest where we go, actually, that's a dupe of other work that we've got. You're less likely to do that if there's something specific that I'd like to evaluate putting this type of workload on. Okay, that's okay. All right. It doesn't have to be a tenured professor. It has to be somebody in a university. If it's a PhD student or a postdoc, that's awesome. That's really good. And they get this as an award. That's actually going to look really good on their CV, the fact that they've managed to justify this. We would definitely encourage people within the research groups to sort of come forward. Typically, you want the slightly older researcher that's maybe been around a little bit. He or she knows how to program. Not that old. No, you want somebody that isn't going to sort of fumble around for the first 6 months, okay, and then realize, I've only got 6 months left of the award. I mean, we can always extend it. It's not a problem. We have training passes that we use for people that take the class, which don't last the full year and they're not as big in terms of footprint. But if you think there's a chance that they're going to want to scale up at some point, I would put in for the bigger award. If they don't use it, it's not a problem. Okay? We over-allocate. All right? We were given this much from the Azure business, and we're probably going to give away a lot more than that, on the basis that not everybody uses everything. This question right there.
So I have a colleague at SDSU who teaches a MATLAB course, and I've already sent her email saying that she should maybe approach you, the MATLAB
pilot thing that you have. One question I have, she actually teaches a class, so do you have services that are set up in Azure for like class,
Yes.
an entire class too? Okay.
Yeah, so
You're going to say no, I was going to ask, are you open to suggestions on what should be done?
So let me tell you what we've got in terms of the educator passes, because they're a little bit different. There's some specific things called educator passes that were used for people that were teaching a class where the typically faculty member wants to issue a number of passes to students for a particular course, a particular semester, and they want to be able to go in and see whether they're using them. Okay, so we have passes like that we can that have been issued. I'm not sure whether we're still issuing at the moment, but the mechanism is there. Okay, there's some funny things go on though, because some people use them in a very responsible way, and some people are a bit less responsible. Like they'll spin up a Hadoop cluster and then leave it running. You know.
That was going to be my other question, is because there might be ways by which you want to put some governors in there,
Yeah.
or some controls. And,
Yeah, we just come and beat people up. That's what we do. Yeah. Which I'm very comfortable with. But then I'm from England, and that's what we do. So
it's more of a suggestion. Actually, Azure you can sign up for free for only 30 days.
30 days.
yeah.
So there's another company called Town. You can sign up for free for 1 year. And this is a feedback from some students. They get busy, they get homework, 30 days are gone.
Yeah.
So is there any possibility to make that learning period be longer, maybe 60 days or 90 days? So at least they have a chance to learn for students. Then after they learn, then we can maybe give them a research account.
Yeah, so we're providing feedback to the Azure team. We don't own those passes, all right? So that's the Azure team. And we're also sort of cognizant of the limitations for those individual passes, okay? There are other forms of passes that would give them longer access. I can't remember, but do you have to put your credit card in for that other company?
I don't remember.
Yeah, I think you probably do.
I think so.
Yeah, you do, and then if you go above the cap, you get charged. With the Azure one, when you hit the limit, you have to actively unlock it in order for you to be charged for it.
So
we
that's
do slightly different
the place where
management.
students get very nervous, right? They don't know what they are getting into.
Mm-hmm.
And they have only 30 days and time's gone. But just wonder whether there's going to be maybe 60 days. So there are few excuses for students to say.
And in part that's why for a lot of the processes that were set up by another part of our business, not that I particularly want to expose the inner workings of Microsoft to you, that's one of the reasons why they went with the faculty model, where they would grant it to the faculty that would then issue the passes. And those were, actually, I mean, they're small, but they're still pretty meaty. They go well beyond what a competitor might have been offering.
Our training passes are good for 6 months, no credit card.
Yes.
Okay.
So the training passes that we issue are 6 months.
Good to know.
But it's great feedback, and yes, it's one we've heard before. But it's good to have it reinforced.
I was wondering about the hardware thing that you showed. That looked really cool. And I could see people building that and maybe integrating it in with like the Lab of Things. And I had sort of two questions. Where do we find out more information about it? And the second question is, can you sort of build the same Lab of Things kind of infrastructure without having that requirement of the Home OS PC there? Because that's a much bigger device, costly device, whereas these other smaller things, you want to throw out these sensors and connect them and have them push data to Azure or something and then analyze it. That could very easily scale a lot more than like a PC somewhere that's doing data aggregation.
So the Home OS piece of the Lab of Things is a requirement for Lab of Things, okay? It acts as that aggregation point. It allows you to update, all right? It allows you to control more in a more sophisticated way the behaviors of the infrastructure that is deployed in the setting, All right, so we went round that design decision, and it's a very clear requirement that you want to be able to update drivers, you want to be able to update, and you can't do all of that if everything's remote, and then you've just got these very dumb clients, okay? If, however, you say, no, I don't want that, I won't have this sort of local aggregation point, the home OS, I don't want that. You can use Gadgeteer or other equipment that you want to deploy and use the service bus infrastructure that there is natively in Azure. And on that point, we sat down, again, it was the first training that we did, it was down in Brazil, and one of the grant applicants, one of our award applicants, would just put in a huge request to a funding agency in Brazil for a whole load of infrastructure that they were going to build out. And we sat with him the day after we'd run the training, and he was grinning. He was just grinning, all right? Because he was pretty sure he was going to get his application approved from the funding agency. And we just saved him a year because of the service bus infrastructure. He said, I was going to build all of that. I'm going to get the money for it, but I don't need to spend it on that because you've done it. All of the message queuing that you want handled in an elegant way, we've already got as part of the service bus, because we have lots of businesses. This is where you benefit from that business use of people programming mobile phone applications that then need to send messages asynchronously up into the cloud, have something done, and then something sent back out. All of that's already there, okay? You can just piggyback on that for your scientific applications. You don't have to use Lab of Things. Lab of Things is just a more sophisticated way of handling certain types of workload, typically clinical, people wanting to deploy and then adjust what they're collecting in a home setting.
Well, thank you.
Great. Thank you, Chris. Thanks.